in this video, since we aren't going to be meeting, I hope for half of us anyway, for the Monday sections, happy MLK Junior Day. What we're going to do in this video is work through the week 2 assignment. This is what we would have been doing in recitation anyway. You may get a little bit more detail than you would there, but the notes are released already. Okay, so even if you're in my Wednesday section, you can still use this video. You are the beneficiary of this extra content. So let's work into the assignment. All right, so this is kind of like an overview of everything that's there. Take the time and read these. Sometimes they can be really helpful. Now, let's start here. Factoring. Yes, you need to know how to do that like super well. For this first one, let me go ahead and turn on my annotations here. For this first one, something I want you to observe, a little key fact, is if you have something like a squared minus b squared, that factors really nicely, just formulaically, to a plus b, a minus b. If you aren't convinced by this, if we FOIL this thing, our first would be a squared, and then we would do our outers, it'd be minus ab, then our inners plus ab, and then our last, that'd be minus b squared. These would cancel, and I'd have a squared minus b squared. So that's kind of a useful little formula. Now, the formula may have like different names from your mathematical exposure. Some of you may have had high school teachers that called it something cute, or whatever the case may be. Mathematicians are really not clever in the way that they name things. They call this the difference of squares formula. You want to know why they call it the difference of squares? Because it's a difference, and there's squares. Who would have thought? If mathematicians named a unicorn, they'd say, "Oh yeah, the horse. It's not called a unicorn. It's called a horse with horn in its head." So it's a good thing that mathematicians don't get to name things outside of math objects. Now, hey, this is actually kind of nice because look, it's a difference. And if I think about this, what can I square to get 9x squared? 3x. And what can I square to get 16y squared? Well, that'd be 4y. For the difference of squares formula, I'm going to have a plus and a minus, and I'm going to have the 3x here, and the 4y I'm going to have here and here. Great. So that's going to be my factorization. As a note, it doesn't matter what order you write the factors in because multiplication is what's called commutative, but it is important what order you write the terms in the subtraction in because subtraction is not commutative, okay? 2 minus 3 is not the same thing as 3 minus 2. Now, here's something I want you to know for number 2. There is not a sum of squares formula. Because if you think about it, what I see some folks do is they'll say, oh, well, I mean, a squared plus b squared is equal to a plus b times a plus b, or rather a plus b squared. They'll say, oh, yeah. I'm not trying to be mean. I'm just going to call this what it is. In math, we call this equation the fool's equation. It is a thing in certain spaces, but it is not a thing in the real numbers. So if you ever find yourself writing that, stop it. If you actually FOIL this out, you'll have that a plus b times a plus b is actually this guy, because when you don't actually like multiply this out and you just say, oh, well, the square distributes, you're not doing FOIL, you're doing full. You're forgetting the outers and the inners, right? So make sure that you are taking mind of that. So guess what? There is no formula for this. This is DNE. In some math classes, they would write prime, right? There's no factors, it's prime. Well, that's not a very useful thing there. So let's go ahead and clear all those drawings. All right, so now you're going to need to factor each of these. Now, some of you are going to look at this second one and go, oh, difference of squares. No, 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 not just yet. 50 is not a perfect square and 98 is not a perfect square. Fortunately, they have a 2 in common. And now something really nice happens. 25x squared is absolutely a perfect square, namely 5x. And 49y squared is absolutely a perfect square. We're just looking at 7y. And we're subtracting those. That is a difference of squares. Now, don't forget your 2. And so we'd get 2. 5x minus 7y, 5x plus 7y. This method of factoring is so fast when you recognize it. So it's really useful to kind of have in our back pockets. In the module for this week, I'll have some YouTube videos for some of these methods of factoring. All right, now for this one, let's start with our greatest common factor. Got 54, 180, 150. It looks like the biggest thing all of these things are going to have in common is 6. Okay. Now, if you said 3 or you said 2, like that's actually going to be completely fine. What you're going to find, though, is, you know, when you look at what's left over, there's something else that you could have factored out. And so you can just factor it out additionally, and then you'd end up with a 6 out front anyway. So we get 9x squared minus 30x plus 25. And that's actually as good as it's going to get. Okay, that's as good as it's going to get. So now I'm going to use my particular method of factoring where I'm going to multiply 9 and 25. I know that this is going to feel kind of grisly, but what we're going to do when we multiply 9 and 25 is we end up with 225. And I want two numbers that multiply to 225 and add up to negative 30. Pause the video and start experimenting with these numbers. If you found them, you've gotten negative 15, 15. So now, don't forget your 6. Just get in the habit of writing it every time. I know it sounds kind of dumb, but it's worth doing. So we get minus 15x minus 15x plus 25. So now I'm going to use factoring by grouping. And so 9x squared and 15x, I've got a 3x in there. So then I get 3x minus 5. And then negative 15x minus 25. Well, okay, I'm going to take out a negative 5. Not because I can, but because that's actually like my best option. And then don't forget your 6. Don't forget your 6. Don't forget your 6. All right, so now I'm going to have stay color coded. So one of my factors, when we say factor each, like that means a complete factorization. So we'd have a 6 factored out. 3x minus 5. And then my red factor was 3x minus 5. There you go. Now I got to do that final step because the blue factors here were the same. So since I've got 3x minus 5 and 3x minus 5 as the attached binomials, those are the same. That gives me creative license, and more than just creative license, like objective reality. I can break those into their own factor, and the terms attached on the outside of those go into their own factor. All right, let's move on. right, for question 3, I'm only going to do one of these problems, but this is linear equations, okay? So remember, for linear equations, let's start with slope. One thing that's really nice about the way this is written, okay, remember slope-intercept form, y equals mx plus b. We know that m is our slope, and b is our y-intercept. The language in this book doesn't necessarily call it a y-intercept. It'll call it a vertical intercept as well in this problem. So technically, we've already been fed 2 parts of this problem. So we're going to go ahead and do this guy here. The slope, m, that's the coefficient of x. We're going to have 8. The vertical intercept, that's the constant term. It's going to be 24. There you go. Now, what's going on with a horizontal intercept? So it's a vertical intercept when x equals 0. Okay. So I have a horizontal intercept when y equals 0. Now, for this particular equation, if y equals 0, I get 0 equals 8x plus 24. And now I just need to solve this equation. I'll subtract 24 from both sides. Divide both sides by 8. So I get x equals -3. Okay, so my horizontal intercept is at -3. Now, if you notice, we need to write our intercepts as ordered pairs. Okay, so I realized I made a goof there. We know that for a vertical intercept, the x value has to be 0. So it'd be 0, 24. And for my horizontal intercept, the y value has to be 0. So we have an x value of -3. Sorry about that. It is important that you input these correctly. When I talk about intercepts, I'm asking where is a thing. So you need to give me an x and a y value. You need to give me a coordinate pair. Okay. So get in the habit of doing that. I'll leave the other one to you all. Now, I'm going to go ahead and do 1999 to 2005 in this video. So what we want to do is find the rate of change. So the way you can think about this is I want to find the slope, okay? Average rate of change, you could think of this as slope. The terminology isn't exactly interchangeable, but it is fine to think of it as the same type of thing. So right out of the gate, in order to find slope, we need these coordinates. We need y2 minus y1 over x2 minus x1. Now, right out of the gate, I'm already given x values, which is pretty cool because that's the year. So if I think about this as coordinate pairs, what I'm given is 1999 and 2005. Good years for music and wine, not much else. Now, we've got y1. So what's the y value and when x is 1999? It's 271. And there's my cat, if you can hear her in the background. Everybody's awake and energized and engaged and sharing their needs. And so then we've got the y value is 295. And by everyone, I mean my animals and my son. So there you go. Now, we're going to go ahead and compute our rate of change here. So we'll say y2, that's 295, minus y1, that's 271. See, there's my son. Good morning. And so then we've got x2. Okay, that's 2005. Minus x1, that's 1999. All right, so then I get 295 minus 271. It's going to be 24. All right, and then 2005 minus 1999, that's going to be 6. 24 over 6, that's 4. So our rate of change is $4 million per year. Now, is it exactly going up by $4 million per year from 1999 to 2005? I mean, certainly not, right? Because we see from 271 to 285, like we actually went up 14 there. Wow. And then this one, we went up 10, like that's crazy. But then we only went up 6. And then we only went up 2. And then we actually went down 2. And so when you averaged all of these up, right? If you think about this, you'd have, okay, well, that's 24, 30, 28 minus 2 is 26. 26. Do you want to know why you got 26? Because, you know, you can do math correctly. So that's a bummer. Sorry about that. Instead of 4, it should be 6.5. 26 over 6, and it's not even going to be that. Heavens. Waking up is hard. Wait a minute. What am I doing? 295 minus 271. This is what happens when you take your arithmetic for granted. And so that should be fine. 24, 30, 32, 30. Oh, because I forgot the minus 6. Oop, doy. So then that's going to be a delta of 24. And I performed that delta over 6 years. So that's going to be 24 over 6, which is 4. I was testing you. Sorry about that. I may end up being able to cut this part out of the video. And when I say cut this part out of the video, I probably cut it out, but I sort of goofed on some arithmetic and I went back and fixed it. All right. I try to do these in one take. Sometimes can be a tall order. So now I want to find the average rate of change here. All right, I'm going to leave you guys to take a look at the notes on this, but all you're doing is you're using the slope formula. And what's really cool is I actually gave you the coordinate points. Now, if you were really slick, you noticed that this was a linear equation. And so the average rate of change is always the slope between any 2 points. So you could just look at this with your eyeballs and say 3, and you're not wrong. But if you want to take a look at the notes for a more rigored way to do it, where you use the slope formula, that's totally fine. Okay. Now, this one's a little different. Requires a little bit more algebra, because if you notice, I don't actually give you the y values here. So what I've got are these 2 coordinate pairs. I've got -3. I don't know the y value. And 3. And I don't know the y value. I need the y value so that I can do my slope formula. Okay. So now I need to find what those are. So let's find what g of -3 is. So I get -3 cubed plus 5. Right. -3 cubed is -27. So then I get -3 times -27 is 81. Plus 5, that's 86. That's my y value. Okay, great. So there's my y value. That's cool. And I'm going to do the same type of thing for 3. So I get -3 times 3 cubed. Really take your time with order of operations here. If you're going to make a mistake at this particular part, it's going to be like a small one, and that's going to be a big old bummer. So I should probably model that, and I'm not going to skip steps. Then we get -3 times 27, because that's 3 cubed, plus 5. And I'll get -81 plus 5. That's -76. Okay, so I got -76. And that's my other y value, which is what I need. Now I can use the slope formula. All right. So y2, we'll say -76 It doesn't matter how we label them as long as we're consistent. Minus y1 is 86 divided by 3 minus -3. Well, that's going to be a plus of 3. That's great. So we know in our denominator we're going to have 6. And then we're going to do -76 minus 86. And we're going to get 162. -162. And -162 divided by 6 is actually -27. Okay. And that's all the homework for this week. Please reach out if you have any questions. Shoot me an email. Let me know if there's anything that I'm missing or that would be of help to you all. Have a great day. Enjoy your Martin Luther King Jr. Day.